Good morning. It's a Friday. It's a beautiful Friday, too. I mean, it's the sun. There's a few clouds, but it's like the sun is beaming in, and it was so nice to step outside and be like, ah. How's everyone doing? We only got a couple viewers this morning. Does that mean it's just people are tired? People are just exhausted? One thing, though, this is live. Like, I think the delay is like a few seconds, which is great. I think I've been testing it and I've gotten it down. So let's test it right now. I want you guys to press 3 in chat. Press 3. All right, it probably took a while to get that open because that was about 8 seconds, and I'm assuming. So I'm going to say another number. So get chat ready to push another number. Okay, so have chat ready. Push 7. Yeah, it's about a 5-second delay. Yes, finally. Now we don't have to deal with these long 30-second pauses while I try and get feedback from you guys, because that was super annoying having all of that feedback. So, any questions on the video? I know on this one there was some confusion of how it was posted on my website or on my YouTube channel versus website, etc. It was on my website, but it wasn't, for some reason it was unlisted on my YouTube channel, which I don't understand why. And it was written as 87-1, which I don't understand why. It's kind of weird. It's kind of weird. So I didn't quite understand that, but I apologize for that. But we have a weekend to review it and go over that still. So, and then you guys can just view this DI video whenever, and we should be a-okay. The other thing that's really important is signing up for Google Classroom. Essentially, I have to create an attendance list of who's been participating and who hasn't been participating. And so signing up for that Google Classroom is going to be the way that I'm going to be able to know that I'm reaching out to my students. So if you haven't signed up for the Google Classroom, please, 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 pretty please sign up for it. Even if you haven't uploaded anything, please attach it to your Google account. Okay, so in graphing these functions, let me pull up the lesson. What we did Okay, so what we did is all we have to do is find all the descriptive information, which is kind of like what we've been going over the past few lessons: points of discontinuity, vertical asymptotes, horizontal asymptotes. Finding things like the X and Y intercepts are helpful. And then plot points to be able to graph it. Sometimes using a Sine chart is helpful, but the plotting the points just to test to see where the graph is, that's going to be the most helpful. And then verify that with Desmos after the fact. So check it on Desmos to make sure that we're plugging everything in correctly. So let's go ahead and let's look at the first problem here in the DI. So we have x over 3x minus 6. And so I need to find all of that descriptive information first. So some of the descriptive information would be like the vertical asymptotes. So if I factor this, it'll be a little easier if I factored out that 3 on the bottom. So I know that I have a vertical asymptote at x equals 2. I don't have a point of discontinuity because nothing cancels out. My horizontal asymptotes, I can find that if I look at the original, the degree of the leading term, they're both 1. So since the degree is both 1, I know that if I reduce the leading terms, so x over 3x, the x's cancel out, and so I'm going to get 1/3. So I have my horizontal asymptote, I have my vertical asymptote. So I could already take that information and put it on my graph. Vertical asymptote at 2. And then a horizontal asymptote at 1/3. So from here, like I said, we can find X and Y intercepts. It might be helpful. We don't have to find them. Mainly just plot enough points to make sure we know where our graph is. So for example, I don't know if my graph is here, 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 or here. Well, the only way that we can figure that out is by actually going through and plotting values. So let's pick some values. I'm going to pick some values on this side first. So what I mean by side is the vertical asymptote kind of separates both ends. So here's my X and Y table. And the values I'm going to pick are going to be, I'll pick 1 and I'll pick 0. If I need to pick more values, I'll pick more values. And then some values on this side of the vertical asymptote, I'm going to pick, so since the vertical asymptote is 2, I'll pick 3 and 4. Like I said, if I need to pick more values, I'll pick more values. So I just need to take them and plug them in. So if I plug in 1, I get 1 over 3 minus 6, so that's negative 1/2. If I plug in 0, I'm going to get 0 over negative 6, which is 0. If I plug in 3, I get 3 over 9 minus 6, so 3 over 3, which is 1. And then if I plug in 4, I'm going to get 4 over 12 minus 6, which is 2/3, because you get 4 over 6, which is 2/3. Now here's the reason why I said that we just need to plug in some points, because if I plot the point 1, negative 1/2, so here's that. And then if I plot the point 0, 0. Now the one unique thing about rational functions is the graphs want to hug the asymptotes. And what I mean by hug them is I can make the assumption that the graph is always going to go towards those asymptotes. So even with those 2 points that I have, that's just to verify to me where my graph is. Is it above the horizontal? Is it below the horizontal, et cetera, et cetera? But just because I have those 2 points, I can automatically assume that my graph is going to do something like this. And if you notice, I drew that graph going closer and closer and closer and closer and closer and closer to those asymptotes, because I can make the assumption that my graph wants to approach those asymptotes. And so same thing on this side, I have 3 and it's 1. And then at 4, it's 2/3. So 4 at 2/3, which is about right here. Does this weird zoom in thing. And so once again, I just need to draw the graph as it's approaching those asymptotes. And so that's all my graph wants to do, is it wants to go up and it wants to get closer and closer and closer to those asymptotes. And this right here, what I have here, this is a sketch of my graph. Now let's look at this in Desmos. So let me pop open Desmos. Let's take a look at how the graph looks in Desmos. So that's pretty close. That's good. Let me type in my There's the vertical asymptote. There's the horizontal asymptote. I'm going to make these dotted just so it's a little cleaner. But there's our graph. If I look at 0, 0, there it is. If I look at where 1 is, 1 was negative 1/3, which is what we got. Oh, did I plug that in wrong? I got negative 1/2. This is negative 1/3. Three minus 6 is 3. That is negative 1/3. I'm allowed one mistake. But it didn't matter. The approximation is close enough. And that's why we plug it into Desmos to take a look to make sure that we're not making any silly errors like that. But it doesn't matter. It's the approximation's about right. At 1, 2, 3. At 3, we got it. And then at 4, we got it. At 4, it's about 2/3. Yep, there it is. So we can always just plug it into Desmos to take a look at it. Okay, so any questions on that first problem there, number 1? Okay, cool. Let's look at number 3. Remember, I'm going to kind of go a little quicker since the delay is like 5 seconds, so I'm not going to wait as long. Okay, so number 3, I have x plus 7 over x plus 3 to the 7th. Okay, so the descriptive information, that's the most important. So I need to know my vertical asymptotes, horizontal asymptotes, and any points of discontinuity if they exist. Nothing reduces, so I know I don't have any holes. I don't have any points of discontinuity. My vertical asymptote, setting the bottom equal to 0, I'm going to get x equals negative 3. And then my horizontal asymptote, I wrote a 7 there. That should be a 2. So my horizontal asymptote, I have to compare the degrees. And so on top, it's a 1. Now, I know we look at this and we say, oh, well, the bottom, it's also 1. But remember, this says squared. So that means eventually that 1 gets squared. So it's actually x squared in the denominator. Well, if it's x squared in the denominator, it's larger in the denominator, which means y equals 0. Any questions on that? Okay. So now drawing my graph, I have x equals negative 3. 1, 2, 3. And y equals 0. So those are my asymptotes. So now, what I need to do is I just need to plot some points to be able to graph it. So some of the points that I can pick would be on this side, like 4 or 5. And then some of the values on this side, 2 and 1. So you just pick a bunch of values on either side of the asymptotes, and as long as you get enough information, we're good. So now, just take these and I plug them in. So if I plug in 4, that's going to give me 11 over 4 plus 3 squared. 4 plus 3 is 7, 7 squared, so it's 11 over 49. That's a really small number. If I plug in 5, that's going to give me 12 over 5 plus 3 squared. So that's 12 over 64. Wow, that is a really small number. If I plug in 2, and there's my dog. So I get 9 over 2 plus 3 squared. So you get 9 over 5 squared, so 25. And then if I plug in 1, you're going to get 8 over 1 plus 4 squared, so 16. Now, all of these values are less than 1. All of them are less than 1. So if I make that 1, the 11/49 is almost 1/5. It's almost 1/5. So that's going to be, I don't know, about right there. Maybe a little, should be a little smaller than that. And then 12/16 is even smaller. That's like less than a sixth. So that's, should be closer, which means it's probably going to do something like this. It's going to hug the asymptotes going this way, and it's going to hug the asymptote going that way. We could plug in a value in a little bit to kind of confirm that, or we'll just look at Desmos to see if that's true. But remember, it's always approaching the asymptotes. Now we have the 2. So at 2, it was 9/25. That is, it's not quite halfway because that's 12. So it's a little less than half. And then the 8/16, that ended up being half. Wait a minute, we got an error here. If I plug in 1, 1 plus 4, Eight over 16, so that's a half. That's, it's doing something goofy. See, if I plug in a 1, 1 plus 7 over, I know this might be blocking. I apologize, I need a little more room. So 1 plus, oh, it's negative. I'm so silly. It's negative. Okay, that's 2 mistakes. Ah, what the heck? That is 2 mistakes. That is too many. Let me reboot this problem. My bad, because all of those numbers there are negative. And I wasn't plugging in negative numbers. No one caught me. I apologize. I got like 30 emails this morning, and so I am so distracted with all the different things that are going on. So, here we go. So we said the vertical asymptote is x cannot equal, or x is -3, because the domain, it can't equal -3. My horizontal asymptote, we already established that's y equals 0. Oh my gosh, why are you doing this colors? There we go. So now, 1, 2, 3. There's my -3. Here, I'll do that in red. And then y equals 0. Okay. So now, xy table. So these values, it's -4 and -5. And then -2 and -1. That's the issue. I was wondering, like, some of these numbers were getting, like, really weird. Okay, so now, first one. -4 plus 7 over -4 plus 3 squared. So that's going to give me 3 over, and then -4 plus 1, 3 is -1. -1 squared is 1. So that's going to give me 3. At -5. So -5 plus 7 over -5 plus 3 squared. That's going to give me 2 over 4, which is 1/2. So plotting those, at -4 we said it was 3. And then at negative 5, it was negative 1/2. And so approaches the asymptotes, approaches the asymptotes. Now, negative 2. So negative 2 plus 7 over negative 2 plus 3 squared. So negative 2 plus 7 is going to give me 5. Negative 2 plus 3 is 1. 1 squared is 1. So we have 1, 2, 3, 4, 5. Is that negative 2? It's 5. And then at negative 1 plus 7 is 6 over negative 1 plus 3 squared. So 6 over 2 squared, which is 4. That's going to give me 3 halves. So that's about right here. All right, and then we draw them hugging the asymptotes. So let's take a look at that in Desmos. So I have x plus 7 over x plus 3 squared. And then my vertical asymptote we said was negative 3. And my horizontal asymptote we said was 0. Let me move that over. There we go. So here's my function, the x plus 7 over x plus 3 squared. X is negative 3, so there's my vertical asymptote. Y equals 0, so there's my horizontal asymptote. And then, as we can see, like it's not symmetrical, right? And that kind of almost replicates that non-symmetry there. Important values to kind of look at. Let's see, at negative 4, we got 3. At 5, it was 1/2, which is good. A negative 5. At negative 2, it was 5. And then at negative 1, it was 3 halves. So those are those values. Any questions on this problem? Okay. So now let us do number 5. So for this one, I get 3x squared minus 5x minus 2. And this is over x squared minus 9. Now, for this one here, a couple of things. We need to factor the denominator. Now, normally, we should also factor the numerator, but I already know that the factors in our, like just doing the factors in my head, it's not going to yield anything that cancels out. So what I mean is this factors here into, so I have 3x squared minus 5x minus 2. That factors into x plus 3 and x minus 3. I'm going to open up this screen here, get some light in here. There we go. So there's no way that this on top is going to factor into that, because one of them is going to have to say 3x, and then one of them is going to be a 1 and a 2 for it to this even work out. So I know it's not going to factor, so that's why I'm not worried about it. So if nothing's going to cancel, there's no points of discontinuity, but there are 2 vertical asymptotes here. So my vertical asymptotes are going to be x equals -3 and +3. Then my horizontal asymptote, we take the leading terms, x squared and x squared, they're the same. So because they're the same, I'm going to divide the leading terms because the degrees are equal. And so 3x squared over x squared, I'm going to get y equals 3. Any questions about that so far? Okay. So now let's put those on our graph. So my vertical asymptote, I have one at -3 and one at +3. And I have a horizontal asymptote at 3. Okay. So with this one here, it's a little bit more plugging in. Part of the reason why it's a little bit more plugging in is now I have 3 spaces, right? I have a space here, I have a space here, and then I have a space here. So I have 3 different spaces that basically the vertical asymptotes are dividing 3 different spaces. Now, to be strategic about this, my graph can do different things. I wonder if I can get a pointer. I got to figure out another writing thing because I really wish I had a pointer. But maybe what I'll do is, if it's a spray, I don't know how this do. Okay, so the question is it going to be up here? Is it going to be up here? Is it going to be down here? Is it going to be down here? So the in-between part, it's an issue in plugging values because I don't know where it's going to hug. Is it going to do like it's going to go up and then back down? Is it going to go up and then do that? Is it going to start up and then curve and go back up? I don't know. And the only way for us to sufficiently know is plug in points. And we keep plugging in points until we actually know what's going to happen with our graph. So probably what I'm going to do here is I'm actually going to pick all the values in between just to make sure. I'm going to pick all the values in between. So on my XY table, I'm going to pick -4 and -5. And then picking all the values in between, I'm going to pick -2, -1, 0, 1, and 2. And then on this side, I have 4 and 5. I have 4 and I have 5. So now you're actually going to plug all those in. It's tedious. It's really annoying, but you're going to plug all those in. Now, just to save us some time, because yes, it is a little tedious, what I'm going to do is I'm just going to enter those into Desmos to get those values, just the table values, and then I'm gonna plot them. So give me a second. Okay. Okay, so for -5, I got 6.125. For -4, I I got 9.428. For -2, I got -4. For -1, I got -0.75. For 0, I got 0.22. For 1, I got 0.5. For 2, I got 0. For 4, I got 3.71. And then for 5, I got 3. Okay. So just using our calculator, right, we construct and we get those values. And so now we just got to go through and plot them. So for -4, I got -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to use blue. So it's going to be right there. For -5, I got 6.125. So 1, 2, 3, 4, 5, 6. So it should be about right here. Now, it wants to hug the asymptotes. So the graph is going to do something along those lines. It's gonna approach and go towards the asymptotes. Now the in-between stuff. So at -2, I got -4. At -1, I got -0.75. At 0, I got 0.22. And then at 1, I got 0.5. And then at 0, I got 0.22. Erase that. At 2, I got 0. And then at 1, I got 0.5. There we go. Okay. So I'm going to expand this just a little bit. I wonder if I can zoom in. Yes. All right. So zooming into this just a little bit. One thing I want to point out, if you notice the curvature, it's starting down here, and then it's going up, and then it's going back down. The fact that it's going back down tells me that it's probably going to keep going down that way. So it informs me of the fact that that's probably the direction that it's going to go. Sometimes it could go down and do a small little blip and then go back up. It can do that. It doesn't happen often. I would say that this is a fair assumption to make, but this is also why, we plug it into Desmos afterwards to kind of take a look and verify, is this exactly what happened? Okay, so that's one thing to kind of be aware of with that. So we know it went up here. Let me zoom in again. So I know it went up, and then here it goes back down, and so that going back down informs me that it's probably going to go down and approach that asymptote there. And then last part, the other side at 4, we got 3.71. So that's about here. And then at 5, we got 3. Interesting. It's actually crossing the asymptote here. So it's probably going to do something where it approaches it. But so we're not going to really spend a whole lot of time on that. There are instances where the graph does cross the horizontal asymptote only for like a little moment, but the end behavior is still the same thing. It's going to approach it. It'll never cross the vertical asymptote. It seldom crosses the horizontal asymptote. So there are instances, and this happens to be one, because 5 was 3, which was our horizontal asymptote. But it's still going to approach it. So the end behavior, if I were to say as x goes to infinity, I'm still going to say y equals 3, because it's approaching towards it. All right, so now let's look at this. Let's verify this on Desmos. So there's my table. Why don't you want to go over? There you go. All right, so here's our graph. And those are the points that I picked. So we did make the correct assumption here. So it did go up and it did go back down. See how it did cross here at 3, but it's still approaching that 3 as x goes to infinity. So it's still approaching y equals 3. But that's a sketch of the graph. Comments or questions on that? Cool. It's just a little tedious. We're literally just finding the descriptive information, vertical asymptotes, horizontal asymptotes, points of discontinuity, and then the tedious part is picking points to be able to sketch the graph. That's the tedious part. Cool. Let us move on. All right, so let's do number 7. The good old graphene, sine and cosine. All right, so we have y equals secant of 3x minus 2 pi plus 4. So we're pretending that it's a cosine graph. I need to take the 3x minus 2 pi and put that between 0 and 2 pi. And I want to solve for x. So add 2 pi to everything. Divide everything by 3. And so I'm going to get 2 pi thirds is less than or equal to x, which is less than or equal to 4 pi thirds. So now I can do the box. So 2 pi thirds is here. 4 pi thirds is here. Add them together and divide by 2. So 2 plus 6, or 2 plus 4 is 6. 6 divided by 2 is 3. So this is 3 pi thirds. And then add these together, divide by 2, you get 5 pi 6. And then add these together, divide by 2, you get 7 pi 6. 3 pi plus 4 pi is 7 pi. That 3 divided by the 2, so 3 times 2 gives me the 6. Scaling this becomes 4 pi 6. This is 6 pi 6, and this is 8 pi 6. So now graphing this, 1, 2, 3, 4. I know that my center line is at 4 because of that vertical asymptote. I'm sorry, so the vertical shift. Vertical asymptote. My brain is jumbled today. Scaling this, so 1, 2, 3, 4, 5, 6, 7, 8. So each of those is a pi 6. So this was my 4 pi 6, and this is my 8 pi 6. This is 6 pi 6. Now my cosine graph, I don't want to block it. So I'm going to draw it up here. My parent graph for cosine normally starts at the amplitude, then crosses, then goes below, then crosses, and then goes back up. So we're going to draw that image. So amplitude, crossing the center line, below, center line, and then back above. Now we said that because of its secant, right? We don't draw the actual sinusoidal wave. What we do is we draw vertical asymptotes where it crosses the center line, and then we draw those parabola-like shapes where the amplitude is the highest point, or the peaks. And so that's one cycle. Comments, questions on that? Now to answer the rest of the question, my domain. So my domain, it seems like if I were to continue on these asymptotes, there would be an asymptote here. Basically, it seems like, here, I'm going to draw it in red. Right? So like it seems like every other is an asymptote. So that means this is an asymptote, this is an asymptote. Those are all asymptotes. So that my graph is going to be in between that. So we can just do intervals. So I can do pi 6 to 2 pi 6. Sorry, 3 pi 6. Messy. So this interval right here is pi 6 to 3 pi 6. And then union 3 pi 6 to, so that's 3, 4, 5 pi 6. Union, and then 5 pi 6 to 7 pi 6, and then dot 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 dot. I've established a pattern, so that's my domain. My range, I'll just write it up here. It seems like nothing crosses in between here and here. There's just this massive gap in between. So it's going to be from negative infinity all the way to here, which is 3. And then union, it doesn't start again until 5. And that goes on to infinity. And then the period, 2 pi over b. And so there's my period. Comments or questions on that? So basically, I was trying to find, for the domain, it's just this green here. And once you establish a pattern, that's all you need. It's just that green. Okay. Last one. 8 or 9. So it says find the missing side of the right triangle. Leave your answer in radical form. So these are those special right triangles. So number 8. It's a 45, 45, 90. So these two sides are equal. So A is, whoops, sorry, this is B. See, I told you, I'm not on my A game today. Man, oh man. So 5 root 6 over 12 is going to be B. And then, because this is T, and this is T root 2. So that means I need to multiply this. So to find A, I have to take this 5 root 6 over 12 and multiply that by root 2. And so you're going to get 5 root 12 over 12. Now that reduces. The root 12 simplifies into root 4 and root 3. Root 4 is 2. So this is going to be 10, because 5 times 2 is 10. And then the 10 and the 12 reduce. And so that's going to turn into 5 root 3 over 6. And that's what A is. All right. Any questions with any of these? Cool. Well, have a good weekend. Like I said, please fill out or sign up for the Google Classroom. That's where you guys are going to be able to submit all of your assignments as well. I'm just going to say that they're all due Saturday. And what you'll just do is you don't have to print the worksheet out. You could just write all the answers down and just look at it, right? Just submit that document, do it on a separate sheet of paper, and just submit that. The code is, I think I posted it on the Discord. I'm not going to put it on this Google chat because other people are going to be able to, if anyone public watches the video, but I did post it on Discord. If you were to scroll up on the Honors Advanced Math tab, here, I'll just message you. Did you get the... I just sent a Discord message. Did you get that, Jackie? All right, I'll just go ahead and get in touch with you about that. You can't find it. I just sent you a Discord message. Did you get that message? Wow. Yeah, we'll be in touch, Jackie. It's also on the San Dimas website. All right. See you, Jackie. Thank you. All right, guys. Have a good one.